Now, if you don't have a piece of paper, if you don't have your workbook, you can use a piece of paper. But if you do, if you think about it, to get my book, if you don't have your workbook, you can use a piece of paper for today's lesson, and then glue that into your science book when you get back to school, hopefully on Friday. Hopefully. If you, otherwise, just any piece of paper will do, just because we're going to look at what the difference between a suspension and a solution is. So I'm going to keep this slide up for about, we'll go with 45 seconds just to get this copied down. There's a fair bit of work writing down here. And then what we'll do is we'll go back and look at what we studied last lesson. Okay. Oh, it hasn't been 45 seconds. Almost. I think we're up to lesson 18. If I've got the wrong number, let me know. But I'm pretty sure that's where we're up to. Okay. So lesson 18, suspensions versus solutions. We will be able to list the differences between suspension and solution. So what we're going to be looking at today is I want to be able to compare, because ultimately comparing means we're going to look at both of these, and I want to know what is the difference between them, you know? What are the differences? What are the similarities, etc.? You know, because ultimately these two things are very different things. Now, they're very different ideas. So let's go back first, before we get too deep into this. Let's go back to talking about what did we talk about last lesson? Last lesson we talked about solubility. Now I said something is soluble, and this is actually what we added to our glossary. You guys remember that we had to update our glossary because soluble is in our glossary. So let's grab a look at what did we say. Solubility is how easily a solute is dissolved. So if a solute dissolves really easily and quickly, we say that it is soluble.
Sir,
example, yo.
I am not doing this one.
Well, because you weren't here. So that means you need to pay attention twice as hard.
Okay.
Okay, so salt dissolves in water because it really, really quickly. You add a little bit of salt and it dissolves instantly. So salt is very soluble in water. Whereas something like sand doesn't dissolve in water. Something like plastic doesn't dissolve in water. Something like glass doesn't dissolve in water. No, we don't need to write this down because you wrote this down on Monday. So you've already written this down. I'm just going back over some stuff. Oh, by the way, who was it? Was it Teresa or Tanisha? I forget who said this, but I added this in for dissolving because someone was talking about this video, and I was like, oh yeah. Anyway, sorry. The reason this happens, by the way, is because whoa. The solute, which in this case is Fairy-Floss, is very, very, very soluble in water, so it pretty much disappears in water. Now, we then did a list of some things that we said were soluble, and then we did a different list of things that we said that were insoluble. So like plastic, sand, glass, whatever, you know. And we had wood. What did we want? Wood, stone. We made a big list of the two of those things, and I asked you guys to write down 5 things. I believe it was. And then we said, well, what happens if you add sugar? How much sugar can you add to a cup of water? You get a little bit and you get something that is dilute. You can add a lot and you get something that is concentrated. And if you keep adding more, then it won't go dissolve anymore. It'll actually sink to the bottom, and we call that a saturated solution. And so then we finished up with this slide here. We said lots of solute in one place is known as concentrated. A little solute in the solvent is known as dilute. So this is something that is dilute, and this is something that is concentrated. Now, then I think, so now what we're going to do is we're going to look at suspensions versus solutions. But before we do that, we need to just do a quick little recap. So let's look at some pictures here. I'd like you to draw these 3 pictures. And the reason I'm going to get you guys to draw these pictures is because I think it's important to have pictures to go along with our words. Otherwise, we'll forget. So remember, the one on the left, U is dilute. Dilute is a little solute, lots of water, lots of solvent. Okay, right, solvent. But concentrated is lots of solute in little solvent. And the last one is saturated. So the last one is too much solute and a little of solvent. So the pictures and the labels as well. Charlize and someone and Serenity just joined. Can I get you guys to say hi so that I can mark you off the roll?
Hi,
Who is that?
Charlize.
Oh, hey, Charlize. Okay, cool. All right, I'll mark you as present. What about Serenity is here. Cool. And then I think I saw Yusrab. I don't know if she joined yet or not. If you did join Yusrab, you need to say hi, either in chat or out loud, either or. Yes, Tara, we are writing that. That's why I've left this slide up for so long. There's a pencil on the slide too. Why did it take you ages to get in? Should have been here on time. We're writing this down. I had to download it. What do you mean? Did you not download it already? Are all your other teachers using Google Meet? Ah. I'm sorry, I always use Zoom. It just Zoom is a lot easier for me to use compared to Google Meet. But nah, Google Meet is not way better. I've used Google Meet. It's not way better. Yeah, easier for you, not me. Yeah, it is easy. As I said, it's easier for you guys. It's not easier for me. And who's important here? You guys or me? You guys are important, but I find it easier for this because I actually can do more things rather than in Google, in Zoom, where it's in Meet, where it's like I can't see all the students and stuff like that. Yeah, but Zoom is easier for me. All right. All right. Can I change the slide? All right, I'm going to change the slide. So these are the three things here: dilute, concentrated, and saturated. So now what we're going to do is we're going to talk about this saturated. Now I think I've already given you guys the slide. But if you haven't, I want you guys to write down saturated, a solution that cannot dissolve any more solute, and then I want you to answer this question below. If sugar won't dissolve in a saturated solution, where would it go? Where would the sugar go if I was adding it to water? So work on this one. I want you guys to say, where would the sugar go if you kept adding it to water? Yeah, it would sink to the bottom. So I would say, so instead of writing down the question, which no, you don't need to write down the question, you could just write, if sugar is added to a saturated solution, it will what? Yeah, it will chill. It will just chill the bottom. I was going to go sink to the bottom, but yeah, chill will do. Stephen, I just read that message. Yeah, because you were a bit late to class, that's okay. But just be aware that on Friday's class, if we're still in lockdown, you have to take notes in the class. You have to have a book ready. But hopefully we'll be back at school. So that won't matter. Same with you, Serenity. You should also have your book. I know that you guys thought it would all be online, but yeah, we've got a lot of work that we have to catch up on. And so I can't really just go, yeah, we're just going to do online work. I've got to actually explain things to you guys and teach you stuff. So that's why. Ultimately, we have to get through this before the end of this term, and I'm worried that we won't even make it there. So let's make sure we focus. Okay, I'm going to jump to the next slide. The next slide is going to be something new. So, well, then it's not really something new, but it's something that's here. So firstly, this is the idea of the different levels here. We've got dilute, which is on the far left. This is just another picture that I can show. Dilute is like, oh, this thing doesn't have much that it needs to hold. This is what I would say is concentrated. It's holding that, but this is what I would call as saturated. This guy's holding so many bags that he can't hold any more bags. If you were to give this person another bag, they'd probably end up dropping it on the ground. The same picture could be used for these three pictures here. On the left, we've got something dilute. There's a little bit of water in this sponge, but not a lot. In this one, we've got concentrated. We've got a lot of water in the sponge. And in this one, we've got saturated. There is so much water that it actually is coming out of the sponge. Just like how if you have sugar, there is so much dissolved that it actually sinks to the bottom. It comes out of the solution. So those are three sort of ideas here: dilute, concentrated, and saturated. Now, if you do get something that's saturated, right, it will, as Phoenix said, sink to the bottom and chill out. So this is so saturated that the sugar sinks to the bottom. And it sinks to the bottom or floats to the top because it can't get dissolved. There's just no more space for it to get dissolved. So we need to talk about this a little bit because not everything gets dissolved that can get dissolved. So what can we use to refer to this? So what we can do is we can say, well, we actually end up with something called a suspension. Now, what is a suspension? A suspension is when you have things that are dissolved and things that sink. Okay, so when things sink, they sink to the bottom because they don't dissolve. So we actually have a name for that. It's actually called sediment. Now, this is an example of apple cider vinegar. It has stuff that sinks to the bottom. Here's my question for you guys in chat. Does anyone know of any kind of liquid where stuff sinks to the bottom? There's actually one that you guys would all know. Orange juice is a good example. Yep, the pulp sinks to the bottom. Anyone know any other drink where stuff sinks to the bottom? Come on, guys. I know that you guys can cold tea, yeah. Soft drink, not really Milo. Milo and soft drink is completely dissolved. They're not the ones I was going for, but you were on the right track. I'm thinking, what type of tea, Serenity? Is it hot tea? Yeah, I'm thinking milk tea. So if I fill this up with milk tea, there are going to be some pearls likely at the bottom. That is a suspension, and the pearls would be your sediment sinking to the bottom. Now this is not like, so now you guys have an excuse to go out and get some milk tea. You can be like, Sir said it's okay because it's for science. Let's see, or bubble cup or boba tea, whatever you want to call it. Okay, now what do we call so suspension? There's a pencil on this slide, so I'd like you to write this down for me, please. Suspensions are, a suspension is large particles mixed with a liquid. The large particles will sink. Okay, so writing this down, please, Sage. At the start, you can see through it. At the start, you can't see through it. Sediments are at the bottom. Example, here's some examples. Dirty water, orange juice, boba tea / milk tea. So you might think, so if you think about this, is like, if you think about muddy water, if you shake muddy water, you can't see through it at the start. If you shake orange juice, you can't see through at the start. Even if you shake boba tea, you can't really see through it. But if you wait and then watch for the pearls to sink, or you watch for the pulp and the orange juice to sink, you can sort of see through it. So we're going to jot this down, and then I think we've only got we've only got one slide left. No, yeah, we've only got one slide left. So we have, I think we've got 2 slides, sorry, but we've only got one writing slide left. So that's the other slide is a drawing slide, and drawings are a lot easier to do. So we'll just get this idea here for a suspension. Where are your full stops? I'm lazy. I'm lazy, Matal. I don't usually put full stops in. I probably should be putting full stops in because these are different slides. These different points. But these examples should probably be like dot points. How long do you guys need to write this down, do we think? Let's go with maybe a minute from now, because there's a fair bit to write down. Now, yeah, make sure you get some examples, because all the time, whenever I ask this question on the test, a lot of students always get this question wrong because they don't have any examples. So make sure you have some examples. Well, Serenity, you're bored, but you should be writing this down in your books. Because you don't have a book, because you didn't come prepared, that's why you're not as engaged as everyone else. And that means that when I ask you for a question on the test about what a suspension is, I hope that you remember this class, because the other students will have remembered it because they've written it down in the books. Now, let's see. Do you guys need longer, or can I change the slide?
Yes, please change the slide. Longer.
Need longer? What do you mean? I'm going to give you another 30 seconds, okay? Because then I'm going to change the slide. I know there's a lot in this slide, but I want to make sure that we get the last little bit done. Okay, and 4, 3. This is the biggest slide, by the way. This has got the most Wi-Fi. Let's move on from here. Okay, so this is just a quick picture I found ages ago. This is a jar of glitter. Now this glitter doesn't dissolve because it's insoluble. But again, if you shake it, you can watch as the glitter slowly sinks to the bottom of the glass. Again, forming a suspension. It's a suspension because you've got some particle that is undissolved at the bottom, sunk. So that's what makes it a suspension. A suspension has large particles mixed with a liquid. These particles will sink. So because these are large particles mixed in a liquid and they sink, that's why this is a suspension. These are used a lot in primary schools, actually, I've been told. Good for people when they get really agitated to calm down. They're just able to watch these sort of things sink, and it sort of calms people down. And they're actually quite easy to make too. So yeah. Jars of glitter. What we're going to do now is we're just going to do the last two things that we need to do for this lesson. Is we need a pitcher, and we also need a pitcher, and we also need a of both of these two things. Sage, you need to stop spamming the chat, or else I'm going to mute you from the chat. So let's see. So how are we going to do this? Okay, cool. So how are we going to do this? So we're going to do a suspension versus a solution. So on the left, we're going to write down a solution. On the right, we're going to write down a suspension. I want you guys to draw two boxes. And in these two boxes, for the solution, we're going to do little dots everywhere. And the little dots represent the things that are dissolved. And in the suspension, we're going to do little dots as well. But then what we're going to do is we're going to do big circles. And most of these big circles are going to be down the bottom of the liquid. I'm going to put one at the top, but yeah. And then what I'm going to do is I'm going to add, back. I'm going to write an arrow, and I'm going to write, this is the sediment. And the sediment is either saturated or insoluble. It either doesn't dissolve or it is got so much. There might be so much salt in this water that the salt sinks to the bottom. Or there might be so much sugar in this water that the sugar sinks to the bottom. That's our two differences. That's our two different pictures, and then we've got one slide left, and then we can finish up for the day, and we can go home. We're already at home. You can sit back and we can relax and just chill out, all right? If we can get this slide done soon, so I'm only going to keep this slide up for about another minute more, just so that you guys can finish it off. Okay, we all good? Can I change the slide now? I want to do this last slide so that we can be done. Can I change the slide? Can I get an A yes? One yes, maybe, from someone? Hello? Yeah, okay, thanks, Ben. Okay, so the last slide. The last slide goes back to our main goal. Our main goal at the start of this was to talk about the similarities and differences. So this is our main writing. This is our last writing slide, and then we're done for today's lesson. So solution, what is similar? What is similar between a solution? What is similar between a solution and a suspension? The thing that is similar between a solution and a suspension is they're both liquid. That's one of the easiest ways. They both can be liquid. They're also both mixtures. What is different about them? Well, solution equals all dissolved. But suspension is not all dissolved. That's one of the things. That's one of the big differences, is it's not all dissolved. The other big difference is that solution is would you guys prefer the word see-through or transparent? I'm going to use, whereas the suspension, you can't always see through it. And lastly, the suspension has stuff that sinks. Yeah, see-through, that's what I thought. So what's similar between them? They're both liquid and they're both mixtures. What's different is in the solution, everything is dissolved. All of the sugar or all of the salt is dissolved. But in a suspension, not all of it is dissolved. In a solution, it is see-through, but in a suspension, you can't always see through it. And in a suspension, it has stuff that sinks. That's the main thing. Ladies and gents, if you have finished that, then we have, once you've got that copy down, we are done. You guys are more than welcome to head out of the class. Log off. Please say goodbye to me before you go. You can just maybe write bye and chat or whatever. But otherwise, we're done if you've copied it down. Those of you guys that were not prepared today, please make sure that you have a book or a piece of paper or a pad to write down your notes on Friday if we are still in lockdown. But otherwise, we'll have to get your book ready. Cool. Yeah, okay, thanks, Serenity, but I'll still let I still have to. Turning to the
Bye, mister.
See you later.